Assalamu alaikum. Bismillahirrahmanirrahim. Good morning, ladies and gentlemen. First, I would like to thank the organizers, in particular Professor Mohsen Abdalami, for giving me this opportunity to present my talk here. I did my medical degree in Tehran University of Medical Science. Then I moved to UCL and I did a PhD in Regenerative Nanomedicine and a fellowship in skin regeneration in the Raft Institute. And then currently I'm in the School of Advanced Technologies in Medicine at Tehran University of Medical Science. Well, the topic that I have chosen is a bit different, so I just new areas in medicine, which is called nanomedicine and also regenerative medicine. So a combination of these in dermatology, which I'm aiming to present in this talk. Nanomedicine is, the word of nano is tiny particles that you can't see by their eyes. If you look at just your fingertips for a moment and then count till 10 seconds, the nails of human will grow 10 nanometers. So in nanotechnology, actually you deal with these kind of tiny particles and you fabricate them, then you use in different fields, in particular in nanomedicine, and some fictional application which is making some nanorobots to go in particular part of the body and do the job and then come back, which is becoming in real life very soon. So I'm not going to focus on that, but just to think that you're dealing with very, very tiny particles measuring viruses and biomolecules in the body, and we fabricate them, we characterize them, and we use them in different fields of nanomedicine. In particular, in prevention, you see that current new vaccines are based on nanotechnology, nanoparticles, like in new coronavirus vaccines. We use in diagnosis, in very, very precise diagnostic tools you can fabricate using nanotechnology. For treatment, you can use targeted treatment or targeted drug delivery systems that I'm going to talk in, I'm going to show you later in my talk. And then in regeneration. The concept of regeneration is a very old concept, but I mean, you can deal with different approaches to regenerate the failed organs and tissues. And in dermatology, you use nano drug delivery systems as a transdermal delivery systems that you can see some of them in this slide, like liposomes, not like solid nanoparticles, nanofibers, and so on. So the use of nanoparticles would benefit you to penetrate drugs in a very efficient way, as well as the release of the drug would be very much controlled. Well, in the other side, regenerative medicine, again, is a multidisciplinary field dealing with stem cell therapy, tissue engineering, in situ regeneration approaches, anti-aging medicine that you, aesthetic medicine, you can practice in different approaches in anti-aging medicine, as well as gene therapy and transplantation and implantation science. This is the whole scenario of regenerative medicine which would change the current medical practice in many aspects. But one of the things that you dermatologists and aesthetic medical staff are always dealing with is scarless feeling. You prefer regeneration rather than repair. In repair, you would have a scar. When there is a wound and there is a wound healing mechanisms, some of you trying to get rid of a scar and regenerate the skin in an efficient way, that I'm going to focus on that in the next slides. But in all the time, our body, because we cannot regenerate very severe losses of tissues and organs, so rather than we have fibroproliferative response, which ends up with scar formation. And normally people don't like a scar. They want original state. and we're trying to, in this field, to reduce the scar and enhance the regeneration capacity of the body. So scarless healing is a desire between the dermatologists and cosmetic medical people, and also surgeons, plastic surgeons that deal with scars. They want to have a scarless healing, and for that, well, we have to do some molecular and cellular arrangement in the tissue in order to reduce the scar formation. Well, within 15 years, I've done lots of studies on the use of nanotechnology in regenerative dermatology, that today I'm going to summarize a couple of results that we've got from this research work that we've done. One of the area that my team is focusing is the use of nanofibrous wound dressing or skin replacement in order to enhance wound healing without a scar, and also skin care and some cosmetic purposes. Some of the publications that we've done in recent years are presented here. Just one, if you look at this picture, this is an animal study of full thickness wound that we created in rat model. And then, I don't know why this is not working. Sorry. If you look at the lower, in the O part, that my laser pointer is not working, but the one that heals much better without the scar is the one that we use nanofibrous scaffolding as a wound dressing system. Well, different formulation we used stem cells on top of these nanoparticles, and cell-free products that I'm going to focus on the next slide on that. In one of the studies that I'm going to focus more on that is we have used again hydrogels as a wound dressing system and isolated exosomes, which are products of stem cells and other cells that you can isolate exosomes, which are potent particles full of growth factors, cytokines, and so on, and then use it as a regenerative purposes. In this model, we use alginate as a hydrogel for wound dressing, and also we isolated exosomes from adipose tissue-derived stem cells that we have taken from the rat fat tissue, and then incorporated those exosomes in the hydrogel and used as a wound dressing to see the effect of exosomes on this particular indication. And then, well, obviously we isolated the stem cells that we had isolated, and then we differentiate the mesenchymal stem cells to the adipose cells, and as well as osteocytes to prove that these are mesenchymal stem cells. And then we cultured them on isolated exosomes. Exosomes are these tiny particles that measures less than 100 nanometer in diameter, and then we use them as a potent agent to enhance regeneration capacity of the body. And if you look at these slides, then the exosomes cause a scratch or migration of the cells to reduce if you test it in a scratch test and create a distance between the cells and then culture them, exposed to the exosomes, then you can see after 24 hours the whole cells proliferated and migrated to the gap, and then it shows that the potency of these exosomes to enhance cell proliferation and migration. And obviously we move to animal studies again, and if you look at the last row at the bottom, you can see the closure of the wound very nicely after 14 days when you use these kind of constructs that is composed of exosomes which are isolated from the stem cells. In another study we did gene therapy using nanoparticles and nanofiber system. For that, we wanted to transform macrophage phenotype from pro-inflammatory to pro-healing. Macrophages are very respected cells in the body. They do all the jobs that we need when you deal with healing, tissue healing, from debridement of the wound, antimicrobial activity, and regeneration activity. Macrophage is very prominent in regeneration process, and macrophage has got two types. One is M1, which is pro-inflammatory. Another one is M2 macrophages, which enhance or promote regeneration of the skin wound. To enhance regeneration of the skin, we can transform M1 macrophages to M2 by some genetic modification using siRNA system. And in this study, we used siRNA, which was responsible to change M1 macrophages to M2 phenotype. Obviously, we fabricated different type of nanoparticles. We modified the surface of these nanoparticles with different materials like polyethylene and chitosan and so on. We have a technology which is called layer by layer self-assembly, and then you can fabricate nanoparticles and then modify the surface of nanoparticles with different agents, considering the charge, electric charge of the particles. And then obviously you can load your genes or your small molecules or your siRNA on top of the nanoparticles and protect them with other layers. That we did here because we wanted to deliver siRNA to the wound, to the cells of target, and then keep them in there and have kind of sustained release of siRNA in a mode that you want. And for that, we did lots of experiments to show the size of particles, different kind of coating, layer by layer self-assembly, and then putting siRNA on top of these nanoparticles as a delivery system. And this is the actual picture of the nanoparticles at the bottom using tunneling electron microscopy system. And for us, it was very important to control the release of siRNA because you want nanoparticles to go to the area of the wound and then stay there for a while and then release the siRNA in the mode that you require in order to transform M1 macrophages to M2 as a kind of genetic modification or gene therapy system. And here you can see the release pattern of the siRNA system. Using different coating, we control the release rate because for us, not only delivering the molecule in the area is very important, the release pattern also is very important. So we did lots of studies to optimize the coating in order to protect the release pattern in the way that we wanted. And obviously we did also different environment to see the release pattern because as you know, wound environment is a bit different from the healthy tissues. You have different pH in the wound environment, so you have to consider those changes in the release pattern. And we did cell viability study in order to see if the construct that we have made is toxic or not. Because nanoparticles can be toxic as well. So in order to reduce the toxicity and enhance the efficacy of these constructs, you need to study the safety profile of these nanoparticles. That we did that, and we've shown that these kind of formulations that we achieved during different kind of coatings was very good for the cells, so there was no problem in cell viability in the time that we studied. And then obviously we went to the genetic profile of the macrophages to see if the formulation is effective or not, and if the required genes that we need to transform M1 macrophages to M2 was efficient or not. So we studied different kind of gene expression systems to see if the macrophages are on M2 phases or not. And the results was very, yeah, just the last slide. Okay, I can manage it. And then, according to the studies, we noticed that the formulation is very good and efficient in changing M1 macrophages to M2. And this is the last slide, the concept that you using kind of nanoparticle delivery systems in the background of nanofiber wound dressing systems, you can do everything that you want in terms of enhancing regeneration capacity of the body, and also some genetic modification of the cells around. You can modify the system in a way to reduce the scars and also to regenerate the tissues rather than having a scar and repair. And this is the last slide. All of you are invited to the Tehran Dermatology and Cosmetics and Laser Conference, which will be coming soon on 4th and 6th of October 2023. And we are very pleased to host all of you guys and scientists from around the world in our seminar and conference. This is the picture of our team in the Department of Medical Nanotechnology. So in the School of Advanced Technologies in Medicine, we are focusing on new technologies like regenerative medicine, nanomedicine, biotechnology, neurosciences, molecular medicine, and so on, cell therapy, tissue engineering. And this is just part of our people in the Department of Nanomedicine in a gathering that we had organized as a Nanomed festival for our students. And thank you very much.